In this module, I will illustrate weighted means and weighted standard deviations. I will explain the need for these and demonstrate how to calculate them both by hand and by SPSS. In addition, I will also talk about some housekeeping matters. To reproduce Table 1 in the Hammermish study, we need to generate new variables. We also need to learn how to identify duplicates and filter data. There are several instances in statistical analysis when every observation in your dataset doesn't carry the same weight, and you have to account for the fact that certain observations carry more weight than the rest. That affects averages and also standard deviations. In addition, the cross tabulations we have produced in the past could also be affected by the weights that differ among observations. Therefore, we need to know how to generate weighted cross tabulations. Let me illustrate weighted means using GDP or per capita GDP for three countries: the United States, China, and Luxembourg. The per capita GDP for United States is $46,000. For China, it's $3,920, and the average per capita GDP for Luxembourg is $107,000. If I were to compute the average GDP per capita for these three countries, US, China, and Luxembourg, I will add these three up and we'll end up with $52,307. That would be a wrong average calculation. $52,000 is rather optimistic when it comes to an average GDP for the three countries. It's more like $11,786, and here's the reason. You see, the three countries have very different population sizes, and therefore a naive aggregation would result in a wrong inference and wrong statistics. The correct way is to weight the average per capita GDP by the population for each country. The formula for weighted mean is presented here. Essentially, you take the population in millions, multiply it with the per capita GDP, that's population multiplied by per capita GDP, and you get three numbers, one for US, one for China, and one for Luxembourg. And then you also sum up the populations for the three countries and then divide this multiplied number, population times GDP per capita, that is 19 million and change, and divided by 1,659, and the weighted GDP ends up being $11,786. One can compute the weighted standard deviation the same way. The calculations are more involved than calculating the weighted average, but fortunately SPSS and other statistical software have built-in routines to calculate both. In SPSS, we essentially can use weighting cases option and weight cases by a particular variable. In our case, the authors Hammermish and Parker had used number of students who evaluated a course as the weighting variable, so you simply select it and click on OK, and that pretty much takes care of it. Once you have weighted the data by a certain variable, then the remaining calculations that follow, all averages, standard deviations, cross tabulations, and statistical models that you generate afterwards will be weighted